For decades, occupational health treated work-related stress and job satisfaction as a single thermometer. If you were highly stressed, you were burned out. If you had zero stress, you were satisfied. To understand what actually happens to the human body under chronic occupational load, we have to discard that single thermometer and separate these states. This grid maps well-being on two independent axes: vertical for activation, horizontal for identification. Burnout locks into the bottom left, defined by drained energy and cynicism. Work engagement operates in the top right, characterized by high vigor and dedication. These are entirely distinct, conflicting cognitive frameworks. Because these two states sit at opposite extremes of our psychological map, physicians logically assumed they must produce entirely opposite biological profiles inside the body. To test that assumption, researchers at Utrecht University designed a comprehensive empirical study to capture the psychological traits and neuroendocrine biomarkers of corporate employees. The investigation focused on a primary test cohort drawn from hundreds of managers working inside a major national telecommunications company. To ensure the data wasn't skewed, the team applied rigorous exclusion criteria. Individuals with asthma, diabetes, cardiovascular disease, or a history of systemic medication use were removed. They needed a completely biologically clean slate. The objective was precise: track the dataset from high-level psychological trait profiling down to the molecular output of the human stress system and see if the standard clinical assumptions held true. Before analyzing the blood and saliva, the researchers first had to prove that these extreme ends of the spectrum, the thriving worker and the failing worker, could be accurately isolated purely by their core psychological architecture. To accomplish this, they utilized a discriminant analysis, a statistical method that sorted an initial dataset of 572 employees, looking for the specific Big Five personality traits that mathematically dictate where a worker lands on our two-dimensional grid. The scatter plot shows the burnout cohort is defined by high neuroticism, a vulnerability to negative emotions that heighten sensitivity to demands. The engaged cohort clustered on the opposite end, defined by low neuroticism and high extroversion, a disposition toward sociability and high activity. But personality traits alone didn't complete the profile. The engaged workers also exhibited a distinct underlying neurological temperament, a concept rooted in early Pavlovian studies of the central nervous system, known as mobility. Mobility is the central nervous system's hardwired capacity to rapidly adapt to new surroundings. High mobility individuals can process sudden changes in environmental demands and transition smoothly between highly taxing activities without losing efficacy. With the cohorts cleanly separated by their psychological and neurological traits, the researchers could finally draw their physiological samples. It was time to look at the biology. Attention shifted from the brain's cognitive patterns to the body's primary engine for managing chronic stress and allostatic load, the HPA axis. This schematic maps the human stress response. When facing stress, the hypothalamus sends a signal to the pituitary gland, routing down to the adrenal cortex. The cortex then releases cortisol, the hormone that mobilizes glucose and prepares the body for high-demand situations. To capture an accurate baseline, researchers measured the cortisol awakening response by sampling saliva multiple times within 60 minutes of waking. They also measured DHEAS, a hormone circulating alongside cortisol that serves as its biological counterbalance, buffering the system against sustained cortisol exposure. In clinical settings, the ratio between circulating cortisol and DHEAS acts as the standard scorecard for physiological exhaustion. A shift toward high cortisol and low DHEAS is universally viewed as the fingerprint of chronic stress. The expectation going into the lab was clear. Burned-out managers should display severe basal dysregulation, and highly engaged managers should display optimal healthy baselines. This line graph tracks the cortisol awakening response across the first hour. Notice the trajectories of the burned-out, engaged, and control groups are visually indistinguishable. Despite being psychological opposites, they produced no statistically significant difference in basal cortisol output. When the researchers analyzed the levels of protective DHEAS circulating in the subject's saliva, they found the exact same null result. Even the cortisol to DHEAS ratio, the supposed gold standard metric for identifying chronic occupational wear and tear, failed entirely. Looking purely at the basal hormone levels, it was impossible to identify who was thriving at work and who was suffering from clinical burnout. This data dismantled a persistent clinical narrative. Burnout is routinely diagnosed and discussed as a state of adrenal fatigue or measurable basal hypercortisolism. But the numbers show that taking a static snapshot of a worker's baseline hormones tells you almost nothing about their true state of burnout. If the baseline biomarkers are identical, we are left with a critical question. Where does the biology of occupational well-being actually diverge? The answer lies not in the static load of the system, but in its dynamic auto-regulatory sensitivity. You cannot measure a car's performance strictly by looking at it while it idles. You have to see how effectively the brakes respond when applied. To test the neurological brakes of the managers, the researchers administered the dexamethasone suppression test. In the dexamethasone suppression test, subjects ingest a synthetic compound mimicking cortisol. When it binds to the hypothalamus, the brain believes the body is flooded with cortisol. A healthy system reacts by firing a downward signal, instantly throttling endogenous cortisol production. By introducing the synthetic compound and measuring how hard the individual system hits the brakes on its own production, the researchers could finally expose the hidden biological difference between the cohorts. This bar chart measures the percentage of endogenous cortisol suppression recorded after the dexamethasone test. Here, the data completely separates. The work-engaged cohort demonstrates a significantly stronger, deeper suppression than both the burned out and the healthy control groups. Biologically, this means the engaged worker's endocrine system possesses exceptional feedback sensitivity. Their biological braking mechanism is highly sensitized and highly efficient at downregulating the adrenal response. Work engagement is not the absence of a biological stress response. Engaged workers still encounter heavy occupational demands and still mount a rigorous hormonal defense. The advantage is their elite capacity to rapidly clear those stress hormones and return to equilibrium. By contrast, the burned-out cohort combines a high neuroticism psychological profile with a sluggish, less efficient internal braking mechanism, leaving them vulnerable to the lingering effects of daily stressors. While trait psychology neatly sorts workers on paper, true occupational thriving doesn't come from having less stress in your bloodstream. It comes from possessing a biological architecture built to effortlessly shut that stress down.